back in action, part 3. We just learned that you can use glycogen in 2 different directions. Where is glycogen stored? Liver and muscle. Now, we learned over here in the phosphagen system that whenever you burn something, you get a byproduct. Yes?
Yes.
So now you're asking, hey, Miss McKay, what are we burning in the glycogen system? And the answer is what? Glycogen or carbohydrates. So here's what we need to understand. Whenever we burn glycogen or carbs, okay, we end up getting 2 different things. The first thing that we end up getting is when you burn it, you get this stuff called pyruvate. So whenever you burn glycogen, you get pyruvate. When you burn glycogen, you get pyruvate. Whenever you burn glycogen, you get pyruvate. Now, pyruvate, depending on what you're asking your body to do, it's going to take it either through fast glycolysis or slow glycolysis. Hey, refer back to your chart on page, what page was that chart? 54. Now, over here when I'm going to talk about fast glycolysis, I'm going to say that this is about 80 to 90% intensity. Because remember, I left off at like 90% here. So I picked back up. Over here with slow glycolysis, I'm calling this 70 to 80%. So got it?
Got it.
Nice. So is this still a relatively high intense event? Yes or no? What does it say my time frame is on those? Okay, so right here, we're going to be like 6 seconds to 30 seconds. And then I'm going to pick up over here with 30 seconds, upwards to about 2:30 to 3 minutes. So what is happening to my intensity as I move to the left? The intensity is going down. So here's what we start to see. Whenever I burn glycogen, I get... Okay, well, pyruvate does this really interesting thing. And come back with me to where we're talking about the glycolytic system on page 46. Now, if you'll see, it has 1 and 2 there in your book. Whenever you burn glycogen, you get pyruvate. Remember, mass action, mass effect. So this with the mass action would be the converting into pyruvate. The effect now is pyruvate becomes lactate. There's some fancy chemistry in here, but we're not going to learn the fancy chemistry. We just got to know what to do with this stuff. So during fast glycolysis, pyruvate converts to lactate, and then over here, since this is a higher or a lower intensity, we actually find someone reaching their LT. What do you think your LT is? Not LJT, but LT is what? Your lactate threshold. And when you get to your lactate threshold, you are truly what? Done. Anyone taken a stress test recently over in the lab? No one has? Anyone done it before ever? How does it feel when you get to your lactate threshold? Like you want to collapse. It's not heart, rainbows, and sunshine anymore, is it? It's kind of that verge of collapsing, the verge of I think I'm going to puke, that point where you really think you're done. At that point, you have reached your VO2 max also. That's another way of thinking about it. You really are done. Here's the sad part. Most people quit before they're done. Because guess what? Being at your lactate threshold hurts. It sucks. It hurts. And most people aren't willing to let it hurt that bad before they just quit. I know y'all have seen people in the labs and they're stopping before they really get to their VO2 max. So you're having to do a progressive regression with the math about where they could have been if they hadn't quit. So we see lactate all of a sudden accumulating. Now, how many of you have heard that lactate is the cause of muscle soreness? Lactate is this villain. Yes, have you heard that?
Yeah.
People are like, oh, I'm sore, I got to get rid of all this lactic acid. Not true. I'm sorry you were taught that. So what we now know, there's some better information out there. So as we see this lactate threshold starting to happen in your muscle, we actually see this giant accumulation of hydrogen ions. So what's accumulating?
Hydrogen ions.
What's accumulating?
Hydrogen ions.
So this is the whole mass action, mass effect. And all of these hydrogen ions are positively charged, which means they're loaded and ready to go. So we have been making lactate or lactic acid the criminal. Lactic acid is not the criminal. The problem here is your body can't do anything with these hydrogen ions fast enough anymore that they accumulate and then you're done. So I like to think about this is, let's just say that there was a convenience store being robbed. You guys, all the lactic acid was, or the lactate was, it was an innocent bystander. It's like, man, I'm in the wrong place at the wrong time because all of these hoodlums, H, hydrogen, all these hoodlums were what started the riot and got us to the lactate threshold, which ended us up in jail that night. Y'all know I like stories because y'all will remember the stories. Okay? So when fast glycolysis happens, this is when all of a sudden something gets out of hand before you're ready. You weren't really, you're like, oh, I didn't see that happening. Kind of like life. So when fast glycolysis, 80 to 90%, 6 to 30 seconds. So give me some events that we can put bookmarks in our brain. What happens at 6 to 30 seconds? 100 meter dash. What? 200 meter dash. What about a basketball player that is still keeping at a relatively high intensity throughout? People start to think that basketball is an aerobic game because it goes on for 7 to 20 minutes. It is not. You guys, like a basketball game lives right here, and then all of a sudden they're letting their bucket fill up so that they can go in for the dunk. So basketball lives right here. A lot of times you might see something, you know, if let's just say a receiver ends up getting a great catch and they get to take it the length of the field, you're actually seeing this lactate threshold come into play. Now, is lactic acid the cause of the problem? No, what's the problem? Hydrogen ions. And it's interesting, we've been looking at sports supplements, which we're always trying to find better ways to do things. We're looking at some different supplements that can help us buffer off these hydrogen ions. One of the simplest things that they're starting to see is, and this is experimenting, so don't go crazy with this. We're starting to see that you can actually take baking soda, which it brings a pH down. Baking soda can help people get beyond their lactate threshold. Because let's just say, someone give me their best 60 time. What? 5.3. Okay. Now, let's say that this was our absolute best 60 time we had ever done. Would the goal to eventually make that, would that be better? Mm-hmm. Here's what we have to understand. You have to be willing to train not only at your lactate threshold, but beyond your lactate threshold if you want to get faster, if you want to get stronger. If you're staying stuck training right here, this will never happen because you're not putting your body in a situation to delay this thing called your OBLA. Does anyone know what your OBLA is? Onset blood lactate accumulation. So once all of this hydrogen ion lactate accumulation is going on, you really get to where you're done. but we have to realize that this is what's going to make us faster. This is going to make us. How many of you feel like you've had coaches press you pretty hard towards your lactate threshold? Did you find out that after that amount of lactate threshold, you really were faster, you really were stronger, and you really were a better overall athlete? Yes or no? Yes. Okay, we're going to take a pause. I'm going to get a drink of water, and then we're going to talk.